Hello all, in today's video we are going to learn about the ICMP and IGMP protocols of the network layer. The ICMP protocol is a companion protocol to the IP protocol. What was about the IP protocol? The Internet protocol is a connectionless, unreliable protocol that does not provide any kind of error reporting or error correcting mechanism. It also lacks facilities for host and management queries. So to compensate these deficiencies, we make use of the ICMP protocol, which is Internet Control Message Protocol, which is a companion to the IP protocol. Let us see what is the general format of the ICMP messages. Now, how does this ICMP protocol acts as a companion to the IP protocol? It has a set of messages which will help us to overcome the deficiencies of IP protocol. So let us see the format of these ICMP messages first. You can see we have the 8-bit type field here, which specifies the type of the messages, the type of ICMP messages, the code of the ICMP messages, the checksum value of the header, and the rest of the header and the data section. What is very important to us in ICMP protocol is we have to know about the ICMP messages. The ICMP messages are divided into two broad categories. The first category is error reporting messages and the second category is query messages. Whenever there is an error and the error message has to be reported, ICMP will report these error messages to the original source which has sent the message. The error reporting messages are of different types. As I told you that in the message format you have the type field. In the message format we had the type field. That type field specifies what kind of messages it is. If it is type 3, the message is destination unreachable. If it is type 4, source quench. Type 11, time exceeded. Type 12, parameter problems. Type 5, redirection. Now we will learn about each one of these messages. Destination unreachable. When does the ICMP protocol reports a message called as destination unreachable? Whenever a router is not able to route a datagram or a host is not able to deliver the datagram to the destination, the datagram is discarded. Because I cannot send it back, we have to discard it. The datagram is discarded and then the router and the host will inform the source machine or the source host that the datagram was discarded by sending the destination unreachable message. By sending the destination unreachable message. Next message is source quench. This is a very important message which is used generally to design, which was designed to add some kind of flow control to the IP. As I told you, Internet protocol doesn't do any flow control. So, whenever a router or host is discarding a datagram due to congestion, you know what do you mean by congestion? Traffic. Congestion is traffic when the load on the network is more and the network capacity is less. Many of the packets or datagrams are discarded. Now, if you have to inform the source machine that due to congestion your packets were dropped or your datagrams were discarded, then you will send a message to the source machine and that message is called as source quench. The general meaning of quench is to slow down. So, there are two uses of this message. The first use is that we are informing the source machine that the datagram was discarded, and the second advantage is that you are warning the source machine that there is a congestion somewhere in the path and that the source should quench or the source should slow down the sending process. So by this you are providing flow control. You are asking the source to stop sending or slow down so that the network the load on the network is reduced, the congestion is reduced, and the datagram loss is also being avoided. Next, the next message is the time exceeded message. The time exceeded message is generated in two cases. If you remember, in the IP datagram format, I told you that we have a field called as time to live, and in IPv6 we have a field called as hop limit. The purpose of this limit this field was that whenever a particular datagram visits any one of the router or the host, the number of hops it makes, they are limited. Each time the datagram makes a hop, the time to live value is decremented by 1. Whenever this value becomes 0, the datagram is discarded. Okay, so whenever the TTL value reaches 0, the source is being informed with a message called as time exceeded. With this, the source understands that the TTL value has become 0. That is why they have discarded the message. That is why they have discarded the datagram. Now, what is the other use of time exceeded message, or when is the second case where the time exceeded message is being sent? It is also generated. As you all know that I told you about the packet fragments or the datagram fragments, where there is something called as maximum transfer unit. If the maximum transfer unit is 1500 bytes and your message size is 4000 bytes, you will fragment the message. You will divide the message into fragments. And if all the fragments of that message are not being received at the destination, then the destination host will send a message called as time exceeded to the source host, telling that all the fragments haven't been received within the time limit. Okay. Next message is a parameter problem message. Now, if there is if you know about the header formats I have taught you in the IPv4 and IPv6, there was lot of information in the header. And if there is any of the header field which is ambiguous, or if there is a missing field in the datagram, in the header of the datagram, then this message is being sent called as parameter problem. It will inform the source machine that there is some problem in the header, or there is a missing value in the header. See, for example, in the header you have the source address and the destination address. And if the destination address is missing in the header, it will be a problem. Where will you deliver the datagram? That is why we send a parameter problem when we have any such difficulty. Then we have a very important concept called as redirection message. For that I'll make you understand the redirection concept. If you see that I have a host A and host B, I would like to send an IP packet from A to B. If you see that the most visible route to route the packets from A to B is through R2. A will send it to R2 and R2 will send it to B. But if you see, A is sending the packet to router 1, and then from there from R1 it has to go to R2, and then from R2 it will go to B. Now this route is a longer route. So now whenever A sends this IP packet to the router R1, every router will have a routing table, and it sees that the best way of sending a packet from A to B is not through R1 but it is through R2. So what it does is, in the first go, because it has got the IP packet, it cannot return. It will send the packet to R2 and then it goes to B, but at the same time it will send a redirection message to the host A, asking it to update the routing table, that if you want to send an IP packet to B, go through R2, don't come through R1. This is called as the redirection concept, where you are redirecting the further messages from A to B through R2, not through R1. This is your redirection message or the redirection concept. Then the second type of messages of ICMP are ICMP query messages. We have error reporting messages and we have query messages. Now these query messages are used to diagnose some network problems. If there are some network problems that can be diagnosed by using these query messages. Let us see what are the query messages. As I told you, the type field specifies the type of the ICMP messages. So if the type is 8 and 0, it is echo request and echo reply, timestamp request and timestamp reply, address mask request and address mask reply, router solicitation and router advertisement. Let us learn about these messages. As you all are aware that ICMP is a companion protocol of IP. So the ICMP packet will be encapsulated in the IP packet. Let us see the messages echo request and echo reply. What is echo request and echo reply? It works just like the ping command, where you want to see that the other device is available or not. It determines whether two systems, either hosts or routers, can communicate with each other. So I will send an echo request. If you are ready for communication, you will send me an echo reply. Echo request and echo reply. Then timestamp request and timestamp reply. See, if I have two hosts which want to communicate, in between I have many routers. Now if I want to know how much time will it take for a packet to go from host 1 to host 2, what I do is I will send a timestamp request message and a timestamp reply message will come back from the host. So this will help me to know the round trip time from the source to the destination. This will help me to know the round trip time from the host to the source to the destination. This also will help me in, if I know the time, I can synchronize the clocks in the two machines. Then we have the address mask request and address mask reply. You all know what is subnet mask? The mask is nothing but the IP address is divided into the network ID and the host ID. If you want to know what part of the address is network ID and what part is a host ID, we make use of a mask /8/16/24/32. I have taught all this to you, okay, in the previous lectures. So if you want to know this mask, subnet mask, then what we do is we will send an address mask request message to the router, and the router will give a reply using the address mask reply which will contain the mask for that particular host. Then the last message which we have is the router solicitation or the router advertisement message. This will help us to check whether the neighboring routers are alive and functioning. See, you are on a big network and there are so many devices and you want to know whether some device is red or a router is there, available or dead, alive or dead. Then what you do is you will send a router solicitation message. When these messages received by a router, it will give a router advertisement message. It will advertise itself that I am available. You can route the packets through me. So these are the messages of ICMP. We are having the error reporting messages and query messages, which will help us to do flow control, some kind of error reporting and some kind of network diagnosis that IP cannot do. Now coming on to the second protocol, that is the IGMP protocol, Internet Group Management Protocol. Let me remind you, it is also a companion protocol of IP. IP protocol can be involved in two types of communication. We can do unicasting or we can do multicasting. If I am doing multicasting, IP will make use of IGMP. Now let me tell you in short that what is IGMP actually. IGMP protocol, it allows several devices to share one IP address so that they can all receive the same data. So I will have a group of devices in a network. They all share one IP address. Any message which is coming will be delivered to a group of devices instead of one device. This is called as multicasting. So basically IGMP is a network layer protocol used to set up multicasting. Now what is multicasting? Multicasting is when a group of all devices receive the same message or packets. How is it possible? You all join a group first. That group will have a single IP address. Any message coming to this IP address will be received by all the devices in the group. It is just like I have a group email ID. If I send a message to that group email ID, it is received to all the people who are in that group mail ID. Okay. Then as we have the ICMP message format, we will also have IGMP message format, where the type specifies the type of the message. IGMP message, maximum response time is how much time it takes to give response to the IGMP messages. It is the checksum used for error detection, and this is a group address. We will have only one address, that is called as a group address. Then IGMP type field, what kind of messages we can have? The type field, general or special query, membership report, leave report, all these are the messages. Now let us see the IGMP messages. There are 4: general query message, special query message, membership report and leave report. These are very simple messages that when you are actually doing IGMP, you are doing multicasting. When you are doing multicasting, you have a group. You have a group of network addresses, or you have a group of devices on the network. If you want to join a group, you will have a membership report message. If you want to leave a group, you will have a leave report group. So you see here the membership report message specifies that a device wants to be a member of that particular multicast group. The leave group message tells that a device wants to leave the multicast group. Then the general membership query and special membership query. The general query is used to learn which groups have members on an attached network. Whereas a special query or a specific membership query is used to learn if a specific group has any members on an attached network. You can see this is how the IGMP operation is. You have a network here. You have a network here. All these are the devices that are connected in this group. You can see these are the list of group having loyal members. So it will have one, see this is the range for multicast addresses. You cannot use any IP address. You have to use multicast address range for multicasting. Okay, so I will have a group of devices connecting to this network, to this group. So any message coming to this group will be received by all the devices in this group. So this is about your ICMP and IGMP protocols, which are the companion protocols of IP. Thank you.